Okay. Okay, so let me continue with this. Okay, yeah. So the references in C++ are, I mean, the best way to think of it, as we started with, was that they are names. Okay, so they are neither they are not addresses or they are not pointers, and we will so in front of you is some differences between pointers and references. So references are not pointers. Okay, this is number one. Okay, so references in C++ are names for, and there are broadly you can say two types of references, right? So one is the normal reference, other is the constant reference. Okay, and at a very high level, you can think about it that the normal reference is a reference to the variable, and constant reference is a reference to a value. It could be a temporary value, it could be a something like a constant that you wrote in the program, or you could just pass references by constant references. In that case, it is also like a value because you cannot change it. Okay, so you cannot assign to it, or you cannot you cannot basically change that reference. Okay, so uh, so this is the understanding, and what we discussed is that one of the main utilities of this reference is this parameter passing to functions, and we discussed a lot of this. Okay, so so just this slide we did not go through in the last class. So so by the way, till any questions or comments till now about references? I yeah. Okay, I think yeah, you can ask later also. So so basically, so what are some of the differences between a reference and pointer? So it is like many of you were also saying that, sir, what is this? This is basically a pointer, but it is not. Okay, so yeah, so pointers refers to the address. Okay, okay, so references, like I said, there can be two types of references, like constant references and all. Okay, yeah, so it refers to the original variable. The normal references, they refer to the original variable. Okay, so so this is number one. Okay, number two is that yeah, so for example, pointer can be null, pointer cannot refer to anything, etc. You don't have that problem with references. Okay, so references will always be referring to something. Okay, either it will be mostly it will be referring to a variable, sometimes it will be referring to a value. Okay, so this is number two. Okay, um, yeah, so yeah, so pointers you can change. Okay, so like here you are defining a pointer. First it is pointing to A, then it is pointing to B. Okay, you can't do that with a reference. Okay, so once you have a reference, okay, you cannot do that. Okay. So now some of the advantages, disadvantages. So first is that because pointers, so one basic advantage is that the semantics with references, okay, when you pass parameters with references or something like that, the way you look at the code, okay, the visual semantics of the code is very intuitive. Okay, as opposed to, see, one of the maybe one of the criticisms of C is that when you write programs with pointers and you write very complicated indirections, okay, it becomes very unreadable. Okay, so it becomes highly unreadable, and that is kind of a big criticism. Okay, so so that is why Java actually does not even allow pointers. Okay, did not allow pointers because it's just Yeah. So C++ it obviously allows pointers for backward compatibility, but so what I would say is that wherever possible, you should use references, and pointers should really be used only when you want to. I mean, exactly, you need the address for some reason or the other. Okay, then only you should use pointers. Okay.
Sir,
This yes.
sir, why does Java not even allow references? Pointers, so that's fine, but it does not even allow references.
Oh, no, no, it allows references. Okay, so in Java, it is something like this. Okay, so so actually this will take the discussion somewhere else.
Sir, indirectly there is a way, or you mean that making a class and inside we do something. Is that related to that?
Okay, we will be sidetracking this. I will just mention a little bit. Okay, so you have to understand C++ is a compiled language. Java is compiled, but there is also an interpreter running. Okay, so this is a big difference between Java and C++. So Java, in fact, mostly uses references. Probably references are used much more in Java than in C++. Okay, but the connotation of reference in Java is very different. Okay, it is so reference is in Java is somewhat like a pointer in C++. Okay, so in the sense that they can be reassigned, they are not just names. Okay, so references exist, different references exist as separate references, and so on and so forth. Okay, and yeah, so and that has implications in other things also, like memory management, which also we will come to. But Java has references. In fact, by default, so parameter passing in Java, except for the built-in types, which is int, char, double, etc., these kind of types, is by reference. Yeah, is by reference, only by reference. Okay, so if you have to do C++ style by value parameter passing in Java, you have to actually make a copy and then pass.
Yes, sir. So that I was saying. There is nothing like a ref keyword or like an ampersand that we can add inside a type, a primitive type. Classes, that is fine. That will only be passed by reference. But for the primitive data types, there is no keyword as such. That's what I'm asking.
For the primitive data types, there is no keyword.
Uh,
I
uh,
understand.
for example, sir, in C# we have this ref keyword. But in Java don't have anything like this. And for example, in C++ we have ampersand. Okay, so that's kind of thing we don't have in Java.
Yeah, okay, yeah. So, but that does not mean you don't have references, right?
Yes, sir, my bad.
Okay, okay. So, yeah. So this was a bit of a sidetrack. Okay. Yeah. So coming back to what we are discussing. Okay. Yeah. So basically, null checking is not needed. So it makes the code faster. Okay. Um, uh, yeah, so other thing is so for example, with pointers you can do all kinds of things, like you can increment pointers, you can take difference of pointers and all. For references, such things are not allowed, and that results in a much cleaner code. Okay, so yeah, and then you can have an array of pointers, you cannot have an array of references, etc. Okay. So this is kind of so this kind of concludes the references module. So any question on references? Okay. Uh, okay. So what? So I will actually stop my video, and now we will go to our next topic, which is today's topic, which is this. Yeah. So okay, let me just open it. Yeah, you are able to see this? Okay. Yeah, so we are going to discuss this another kind of addition in C++, which is the function overloading. Okay, and we will also discuss default parameters. Okay, so okay, so now we so this is kind of so what you are seeing here in this slide, okay, in the left is a prototype, okay, of a function, okay, which is the create window function. So I don't know exactly this function, but it is something like in Visual C++, you can create a GUI window with this function. Okay. Okay. So this is just some function. Okay. The reason for bringing this particular prototype up is that this is an example of how complicated function prototypes can become. Okay. So this has, for example, 11 parameters. Okay. And this on the right hand side, and yeah, so this has 11 parameters, and many of them you can have default parameters. Okay, so in the right hand side we are talking about a call to this particular function. Okay, and you can see, so what you can see is that for 4 of these guys, x, y, something, it is saying some sort of a default. It is passing some sort of a default. And for 3 of the other parameters, it is passing null. Okay. So these are kind of default parameters. So most of the times you will, out of these 11 parameters, you will not be using these 7 parameters. Okay. Okay. But your function call will look this complicated. Okay. So this is an extreme inconvenience. Okay. So in order to solve this particular problem of real programming, that your function calls are becoming very, very bloated. Okay. C++ introduced this mechanism called default parameters. Okay. So what is a default parameter? So default parameter is something like this. Okay. Here we are defining this function, identity function. Okay. And it has a parameter a, which is of type integer, but also we are saying at the time of defining the parameter int of a equal to 10. Okay. And then we are doing something, and this is also returning a. Okay. Now in the calling function, the main function, we can say identity function x. Okay. So which is the normal way of calling this function. Okay, where you are basically saying that this x is a variable of type integer, so its value should be passed to the parameter a, right? So this is the normal call. Okay. um, the second call uses this default parameter. Okay, so in this case you are not passing any value. But the function actually takes a value as input. Okay, takes an integer, but you are not passing any integer here. Okay, so what happens? Why is this allowed? So this is allowed because you have given a default value for this parameter a, which is in this case 10. Okay, so what will happen is it will take, since it has not seen a value for this parameter a, it will take the default value as the value and execute this function. Okay, so clear what are the semantics of the default parameter. Okay, so it is very intuitive, right? So you can call it like this with the parameter. You can also call the function without the parameter. Okay, and as you can understand, you can do this with multiple parameters. Okay, so that is probably where yeah, so you can do this with multiple parameters. Okay. Okay, yeah. So here you can see here is a function with 2 default parameters. Okay, and now so if you have a function, okay, with 2 default parameters, you can Okay, so basically you see you can make all these calls. Okay, so you can call with both. So here both A and B are passed. Okay, so it will be so yeah, so that is the first normal call. So A and B are 5 and 6, so it will print 5 plus 6. Okay, now here you are calling it with only one parameter. Okay, so and you're calling it with x. So the question is, which parameter is it? Okay, so here the thing is that this value assignment to parameters happens from left to right. Okay, so because you have passed only one parameter here, okay, it will get assigned to A. Okay, so you will get 25 because you have passed 5 here. Okay, and B will take the default value, which is defaulted to 20. Okay, so it will print 25. Okay, and if you don't pass, so you can also make this call where you don't pass any parameters. Here, of course, both of the default values will be taken and you will get 30. Okay, so this is the semantics of default parameters.
Sir, in the second call, sir, here
Yeah.
if we do add and in the parameters we pass a blank, comma and then x.
No, that is not allowed. That will give a compilation error.
So there is no way to assign x to b.
Yes, yes. So if you have to, so that is the thing. So if you have to assign something to B, you also have to assign something to A. Okay, so you could pass
Okay,
10
sir.
to A, but in that case, you also have to pass, yeah. So, right? Okay.
Yes.
Okay. Yeah. Okay. So, yeah, so C++ allows programmers to assign default values to the function parameters. Okay. Default values are specified while prototyping the function. So this is another thing that you have to, specify the default values at the time of prototyping it itself. Okay. Yeah. Um, Okay, so default parameters are required while calling the functions with fewer arguments or without any argument. Okay, so this we have seen. Better to use default value for less used parameters. Yeah, so this is basically the thing that what you are. So you can think of yourself as like a designer of a library. Okay, so in this library you have you have given a function which can allow a lot of functionalities. Okay, so so what you can do, you can say that but only some of the functionalities are more widely used and they require so a lot of functionalities means I mean it will basically take in a lot of arguments. Okay, but then you can say that only some of them are uh, usually provided, others go to some default values. Okay, so in that case what you can do is you can put towards the beginning, so at the time of writing the function prototype. Okay, uh, you put those variable or those parameters which are used more frequently towards the beginning of the parameter list. Okay, so that is what you should do. Okay. Yeah, and yeah, and for the rest of the parameters, you should provide like default values. Okay. Um, mm, yeah, so the default arguments can be expressions also. Okay, so yeah, okay. Okay. Um, yeah, so now, so
Could
this
you
is
please tell the last point of the last slide?
uh,
Yes, sir. Last.
Yeah, so you have to provide a value, default value, right? So this default value can be also an expression. Is this clear?
Oh, okay, sir. Got it.
So expression means can we assign the previously initialized variables like
Yes.
here in prototype int a equal to 10 and the second one int b equal to a.
Yeah. So b is equal to a will be allowed. Yes. Okay.
Okay, sir.
Okay. So okay. So now yeah. So like we said, so at the time of defining functions with default parameters, okay, you have to follow some restrictions. Okay, so what are the restrictions? Okay, so the first is that all parameters to the right of a parameter with a default argument must have default arguments. Okay, so so you see, for example, look at this function declaration here. So this is f. You are declaring this function. So you have declared the type of the first argument, okay, which is int. Then the type of the second parameter, which is double, and then you are saying its default value is 0.0, and then you are defining a third parameter whose type is pointer to character. Okay, now you see this particular thing does not have a default value. Okay, so this will give a error, okay, at the time of compilation, and the reason it will give, so the reason this is there is that you're, like we said initially, that what you do is you start assigning default values to parameter from the left. Okay, so now what happens is you can never you will never be able to use this default value 0.0. Okay, because you when you are giving two arguments, it will take int and char star. Okay, so sorry, so if you give two okay, mm, so the way to put it is yeah, so basically always have to provide three arguments. Okay, because it is assigning arguments to parameters from left to right. Okay, so that is the way to think about it. Okay, so this is not even allowed. Okay, default arguments cannot be redefined. Okay, yeah, so you cannot say so this is not allowed. Okay, so you cannot say that there's a function g with the first with the default argument double equal to 0, and then again you redefine it as double is equal to 1. Okay, and of course all non-defaulted parameters are needed, so you have to provide parameters which are not defaulted. So these are the restrictions. Okay,
Sir,
yes,
sir, in the means for the first parameter int, we are not applying any default value. So this won't give an error.
which is, by this you mean what exactly?
Sir, for the first parameter int, sir, like we
You-
should also have to do int is equal to 0, no, sir? But we have not done.
For which one, G or F?
Both, sir, G and F both.
No. It is okay. So the if you take if you move if you don't have this redefinition, okay, if you don't have this line, the first definition of G is perfectly fine. It is not that you have to provide default values for all parameters. Does that answer your question?
Yes, sir. So why it is giving error for the parameter 3, sir? Like char star in F.
Because it is taking it as a redefinition. Okay. Okay, so it's a read. So you are redefining the same function. So that is not allowed. Okay, so the same prototype is there.
F.
Yes, please go ahead.
Sir, in F, for the third parameter, we are not setting the default value is equal to null. Char star is equal to null. We are not doing that, and this is giving the error missing default parameter for parameter 3.
Oh, you are. So you are talking about a function call. Which line are you talking about? You are talking about
This F
call.
void F int double equal to 0.0 char star.
Yes. Oh, okay. For the F, yes.
So, sir, here we are not giving the default value char star equal to null, and it is giving the error.
Yes.
So, sir, why it is not giving the error for int?
Because read this first thing, right? So it is saying that all parameters to the right of a parameter with default argument must have default arguments. So int is not to a right of any parameter which has default arguments. That is why it is not giving any error.
Okay, okay, sir. Thank you, sir.
Okay.
So,
Answer the
so
second.
do we not need to write a variable also like int A or int B like in this FG?
So you are just prototyping it. Yeah, you are just prototyping it.
Okay, sir. Okay.
Answer the second error is
You have to give the name of the variable, the parameter. Yeah.
So sir, while we are writing the body of the parameter, so there also we have to this initialize the default parameters again.
Yes. Yeah, I think so. Yes. I think you have to initialize it.
Okay.
answer while in the second function that is G, the error is due to the redefinition of G or due to the redefinition of the default argument.
Yeah, it is. It is redefinition of. So it will give the error as the redefinition of function G.
So, but sir, we can overload the function G. We can make another definition of G in C++.
We will come to function overloading. How you can so you can only do overloading. So let us come to overloading. At that time we can discuss. Huh? Okay. Okay. Let us proceed. Okay. Okay. So yeah. So the other thing is that you see the default parameters should be supplied only in the yeah. So in only in the header file. Okay. So okay. Yeah. So yeah. Okay. Okay, yeah. So actually, yeah. So actually, that's yeah. So that's a point. Yeah. So actually, it's the other way around. Okay. So I think somebody just asked earlier. Yeah. So actually, you have to give the default parameter at the time of prototyping. So if you do the definition at the time of prototyping, then you combine it. Okay. But otherwise, if you are doing a separate declaration and definition at the time of definition, you don't provide the default parameter. Okay, so basically, and since you are doing the so normally you should only do the do the prototyping in the header file. Okay, so you should provide the default parameters there. Okay. 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 So this is fine. Okay. So this is
Sir?
about default parameters. Any
Sir?
question? Yeah.
Yeah, so like for the before slide, like if like there could be a possibility that we are not prototyping and like directly definition we can give, right, sir? Like for a default parameter.
Yes. So that was the here. Okay. So where we were just defining. I mean, so declaration and definition was all together.
Yes, sir. And sir, for that header file thing, like if I were to define again the default parameter by defining, would it be wrong or is it not required?
Yeah, so it is not required, definitely. Will it give an error? I'm not 100% sure on this, but it is not required. Okay.
Okay, sir.
Here also we are redefining the function G twice in apps.cpp. So won't it give an error?
Okay, let us see this. Okay, so in the header file you are doing this. Okay, and then in the apps.cpp. Okay, so we will come to this. Okay, so this is actually a new overload. No, this will anyway give an error because it has a non-default okay, so this one let me take it because normally this should give an error. Okay, because you are doing a yeah, so this should give a redefinition error. Yeah, so this should give an error. So according to me, I will just check and get back to you on this one. Okay, let us yeah. Okay, yes.
Sir, calling only G without any parameters, how is it printing 00A?
Yeah, so this one so let me check this example. Okay, so it's not clear to me, this one. Okay, so I will stop the discussion on this one and I will do the discussion on this particular example later. Okay, I think let us go ahead. So unless other than this, any other questions on default parameter? Okay.
Professor Shorangshu, may I come in on that earlier issue?
Yeah.
The question here, friends, is see, the header file already has a function G defined with 3 parameters. That's the first premise: int, double, and char. And of that, the third parameter is defaulted. The first two are not, right? So in the application file, when you are writing the first so-called redefinition of G, just look that you have written int I, double F is defaulted, and nothing is said about char. Why is nothing said about char? Because the char is already defaulted. So this G becomes a function which has one default parameter, one non-default parameter I, and 2 default parameters. Then in the next line, you are providing yet another overload by defaulting even the first parameter. So actually you have 3, kind of incarnations of G. One that has one default parameter, the third one that has second and third, and one that has all 3 of them defaulted. Therefore, G can be called in 4 different ways. using no parameter at all explicitly, which we'll call the third version, using one parameter, which we'll call the second version, using two parameters, which we'll call the first version, and using three parameters, which we'll call the first version with the specific value of char which is provided. Right. So these are notational variants that are provided in C++ in terms of default parameters. Does that clarify the question?
Sir, but in the previous slide, we also defined G twice, but that throws an error.
Please go to the previous slide, to Professor Shurangshu.
Yeah.
Yes. You have just see, watch the differences very carefully. Here, the redefinition is actually in terms of defining. The first one is giving you error because you have not defaulted the third parameter, which is clear. In terms of the two G's, the redefinition is in terms of the value that you are defaulting with. Here, the redefinition is not that. Here, it's not about the. Here, in this example, you had double having default parameter 0 in the first one and default parameter 1 in the second one. So it says that it is a redefinition error because you are having the same function signature. The function signature is first one is non-default, second and third are default. That is the function signature. But the value that you take for the default in the second parameter is different. It's inconsistent because the compiler has to set a value, right? There's no magic. Where is the default value coming from? The compiler is setting it, right? So which one the compiler will set? Will it set 0 or will it set 1? It cannot decide that. So you get a redefinition error. This redefinition is not on redefinition of the function signature particularly. It's redefinition of the default parameter. That's why the explanation, you can see it is redefinition of default parameter. Please go to the next slide, Professor.
But sir,
yeah.
Excuse me, sir. In the previous, please go to the previous slide. So if
Yes.
we redefine the G in this way that double is equal to 0 and we given default parameter to int equal to 0 or 1, so will it give a error or not?
No, if that is the case that we are showing in the second one, because then the function signatures become different. Here, between the header file definition of G and the first definition in the application file of G, the signatures themselves are different. The first one has a signature of first two parameters being non-default, the third being default. And in the second case, you have one parameter which is non-default and two parameters are default. And it is a syntactic reason, and it is a reason of redefining the initializing value, for which in the second definition you cannot write char ch default value character A.
So in the definition of second function, the first value is defaulted int I equal to 0. The second value double f is not defaulted, and the third value char ch is defaulted.
No,
So
it's not. It cannot.
means
See,
double,
this is a sequence of definitions. Overloading is a sequence of definitions. You cannot take them out of the context. So this definition holds in the context of the previous one. The previous definitions are, you have int double non-default, char default. Then you have int non-default, double and char default. So you are overloading that. In that context, you are overloading G to say that int is also defaulted. For the parameters already defaulted, you use the values from the previous definitions. Because you are not allowed to redefine any already defined default parameter constant. Because the compiler gets confused which value to use. It's as simple as that.
okay. Means in
Does
this
that make
case,
it clear?
it is also defaulted.
Right?
Yes, sir.
Clear? Any?
Okay.
Sir, I had one doubt. So
Yes.
whenever we redeclare a function prototype, like one line after the other, so the later function prototype will use all the information which it has in the previous function
It
prototype.
has to be distinct. See, for overloading, if you are redefining a function, what does redefining mean? That you are defining a function with the same name, right? That is redefinition.
Yes.
Functions are identified by their name. Okay? We have not yet gone to classes, member function, any of this. So we are just talking about C extensions in C++. So we are talking about global functions. So global functions are only identified by name. So a redefinition means that a later function has the same name by, by which one or two signatures have already been provided. Now, it is a valid redefinition for overloading if this redefinition signature differs from the earlier ones in some way or other. That could be in terms of number of parameters, that could be in terms of the types of parameters. Professor Shorangshu will discuss that. You can see on the left panel, it is there. The next topic itself will talk about that. So let's not break our head on this. Here, the basic rule that is applying that as we progress one after the other, more and more parameters we default, we are actually allowing the required number of actual parameters for the function call. So the compiler will decide which particular G to call based on exactly how many parameters you provide. Rest of the parameters it has to issue.
Let us say the third prototype, right? The first one means the third prototype in which int I is initialized. So that is by default using the information of the previous prototypes for default values of parameters.
Yes.
Right? Yes. This is done by the compiler itself.
Yes.
Okay.
Yes, that is the reason we need to understand that. See, the compiler is our vehicle to translate this to the machine language which actually runs. So what we understand and what the compiler understands has to be identical. And what the compiler does has a extremely well-founded rationale. Compiler is extremely rational, logical. Compiler does certain thing in certain way because otherwise it will create confusion. Otherwise it will mean ambiguous programming for all of us. That is the basic reason. So with this, when you call G without any parameter, out of these three signatures, it has to be the last one. Okay? Because no other can be called without any parameter at all. Are you getting me?
Yes, sir.
Okay. Professor Shorangshu, I'm done, please.
Yeah.
One second. Sir, can you please once again repeat for the four functions, which one is calling which one for the four Gs?
I would suggest, we have discussed the principle. I would suggest that you run, you put within this function, you put appropriate print versions. Yeah. Pass a parameter, which is the name of the instance. Compile, run it, and find out.
Sir, the first G function should not be commented out.
Which one?
The first G, where character is defined as a.
Why? Otherwise it is a redefinition. If you do not comment it out, because you are including myfunc.h where it is already there.
Okay, sir.
So it is put as commented out there. Understand these styles. Somebody who opens up apps.cpp sees these comments and know that G is already available like this. Otherwise, that person will have to go to myfunc.h, open it and see what is defaulted. Right? So this is given as a comment for readability purpose, not for the computational purpose. You cannot give it as non-comment because in that case, it becomes a redefinition. Clear?
Sir, one last thought. So like, why are we defining it in the header itself if we can overload it? Like we can define the default parameters in the source file.
Because you want to overload it and use it in your app. That header is used by 10 other people who do not want these overloads.
Okay,
but there are mutual calls between your applications.
Yes, sir. Got it.
Right. You have to understand the header and source separation. Header is something that the world uses. That world could be your peer group of developing team. It could be your external customer, but header is through which you say that this is the information required for you to use the code that I have developed, right? Now, anything on top of that is local to your development. And that could happen in terms of header also. You can have global headers, you can have local headers. Right? We will talk about all this in the source organization later on when we talk about the engineering aspects. But the basic principle is always every definition that you need to just use the code should go in the header. Like has defined, like const int, like different global variables. If you have, it's a bad idea, but if you have all functions, subsequently classes, they will go on the header. Their implementations must be on the different application files, because to use that function, to use this G function, you do not need to know myfunc.cpp. That could be private to the company who is providing this support to you. But as a customer, you need to know myfunc.h, otherwise you cannot use that G. Are you getting me?
Yes, sir.
Clear? Thank you, Professor Shorangshu. I stole a lot of time, but I thought a discussion on this would be good.
Over the time for this one. So maybe what we will do, we will just discuss briefly function overloading. Okay. And then we will continue. So now, so you have seen the default parameters. Okay. So there is the other facility which is provided in C++, which is the function overloading. So we are sort of demonstrating this with a particular example here. Okay. So the overall problem here is that you want to do different types of matrix multiplications. Okay. So you have specifically 3 different types of matrices. One is matrix, which is, in this case, we are just saying it is a 10 cross 10 matrix. Okay. Another one is a row vector, which is 1 cross 10 vector. So it has 1 row and 10 columns. Okay. And there is a column vector, which is it has 10 rows and 1 column. Okay. So these are the 3 types of data that you are defining these types, let's say. Okay. Now you can have many different types of matrix multiplication. So first of all, you can have a matrix multiplication. Okay. So here you have A, which is a 10 cross 10 matrix, and B, which is a 10 cross 10 matrix, and your output is also going to be a 10 cross 10 matrix. So appropriate output will come. Then what you can do, you can have a matrix column vector multiplication. So you can pre-multiply a matrix with a column vector. Okay, so this is one form of multiplication you can do. You can do a row vector matrix multiplication. So you can pre-multiply a row vector with a matrix. This is another thing that is available. Then you can pre-multiply a column vector with a row vector. Okay, and you can also pre-multiply a row vector with a column vector. So pre-multiplying a row vector with a column vector basically leads to, as you know, a single number. So this is like the dot product. Okay, whereas this one, pre-multiplication of column vector with a row vector, this results in a 10 cross 10 matrix. Okay, so you can just check the calculations. Okay. Now this is the C version of it. Okay, so where you have to really define all these function prototypes separately, function prototypes, and also you know, the definitions, the names have to be separate. Okay, but you know, they are really sort of doing the same computation. Okay, so they are so you know, you should be able to do so all of them are doing basically matrix multiplications of some form or the other. So you should be able to have one single function, and based on the type of the data supplied, the particular function may be called. Okay, so that is basically what function overloading achieves. Okay, so in C++, you can do something like this. Okay, so the same thing. This is a matrix multiplication. This is matrix multiplication, pre-multiplication of matrix with column vector, and so on and so forth. Okay, but the name is the same. So what happens? See, the function body for all of these things will be different. Okay, so what happens in this case is that based on the type of the argument, okay, so the name is always the same. So based on the type of the argument, the appropriate function will be called by C++. Okay, so this is a very this is a very basic feature and of C++ and also of object-oriented programming. Okay, so so this is called function overloading, or also called static polymorphism. Okay, so what is the polymorphism here? The polymorphism, you see, is that so the language is allowing you to define multiple forms of the same function. The function is the multiply function, but you are defining multiple forms of the same function. Okay, and based on the way you are calling it, okay, so based on the basically the parameters, the types of the parameters, it will the language itself will dynamically decide at compile time, not dynamically decide. So we will see dynamic polymorphism later. At compile time itself, the language can decide which particular function to call. Okay, so that is why this is called a static polymorphism. Okay, so any questions? I hope the word polymorphism here is clear to everyone. Okay, any questions?
Sir, can we do function overloading by changing the values of default parameters?
Yeah, so we will see that actually default parameters are sort of implemented using function overloading. So we will come there. Okay. Yeah.
Sir, I have one doubt.
Yes.
Sir, we have to write the function body again and again for all of these 5 functions.
Yes, you see the reason is that okay, so see okay, so you anyway have to write the function body again and again, because you see in the first case it is a different operation, in the second case it is a different operation. Now I think I get your point. So what you're saying is, sir, instead if we could just take this the row size, number of rows and the number of columns, then we could just do it in one this thing, right? That's what you are saying?
Means if we just have 5 functions with the same name and 5 functions with different names, like how will it help much?
Yeah, so this is just to explain the polymorphism idea. Okay, this may not necessarily be the best design, okay, of this, but even so for example, in this case it is let's say it is matrix multiplication, but you can think of it as maybe multiplication of complex numbers, multiplication of real numbers, and yeah, like that. Okay, so so in that case again you have to have different formula. Okay, and hence but it is the same multiply function. Okay, and depending on the target, the argument type, you can basically the compiler will choose which function to call. Okay.
Excuse me, sir.
Yes.
Sir, if we write the same, like the first multiply function, if we write it the same, just differ the return type, will it be function overloading or will it return an error?
Okay. So if you change the return type, it does not become function overloading, because can someone say why? So the reason is that return type is not specified at the time of function call, right? You don't specify that. So you, by return type, you mean this void argument, right?
Yes, sir.
Yeah. So because at the time of call, you are not specifying any return type, right? So the compiler does not know which version to call. You are specifying the type of the argument that you are doing. So we will see there is a whole process of overload resolution, but the return type. So how is the overload going to be resolved, right? It will be based on the type of the argument. Okay. So yeah, so today we don't have time to go into overload resolution, but that is the next thing we will do tomorrow. Okay. Yeah, so you will see then. So the answer is no. Okay.
Sir, if we change the return type, then it will throw an error.
If you change the return type, will it throw an error? Okay, so yeah, so it will okay, yeah, it will throw an error. Yes.
Sir, but you said that like generally the which function is going to be called is being decided by the input parameters to the function, right, sir?
Yes, yes.
So sir, like suppose if one of the multiply functions had a return type which is something different and it had a different set of parameters. So why would the compiler bother about the return type? Like according to the different parameters, it would call that and it would return it accordingly.
Right. It wouldn't. Okay. But it will bother if you have the same type of input arguments and just the return type is changing. So thanks for, yeah. So just to clarify my previous statement, it will throw an error only if you have a redefinition of the function with only the return type changed. If other arguments are changed, then it will obviously not bother.
Okay, sir, it's clear now.
Okay. Okay, so I think so we will stop here today, and we will go into the yeah, so the details of overload resolution in the next class. Okay. Any other questions or comments?